In this video, we're going to use Ohm's law, that's V equal IR, right, for particular resistors, say for that resistor there. Now, you're used to doing this for full circuits. We've done it a few times now. For instance, here in this circuit, using the blue sheet method, of course, voltage equals 6V, resistance is 6 ohms, 4 plus 2, and we don't know our I. Using VR and I can find this formula. I use this format of V equals IR. Just plug in the 6 on top, 6 on the bottom, and we'll have a current of 1 amp. So that's doing an Ohm's law calculation for the whole circuit. Now, when I say do it for a particular resistor, I mean do it right here. Use V, I, and R for that resistor. And do a similar calculation from the last slide, but just here for that resistor. Now, by the way, this is a series circuit. It only has one pathway for the current to flow, like this. We also have parallel circuits, don't we? Where we have more than one pathway. Here we have two pathways, don't we? The current can go here, the inside pathway, or the outside pathway. That's a parallel circuit. So here, let's say we're going to deal with a calculation over that particular resistor. Well, then we want the V and the I and the R for that resistor only, not for the whole circuit. And we'll do calculations for individual resistors. First, let's talk about current in resistors. This is a series circuit, one pathway. And note that since there's one pathway, there's only one current. It's 1A here, it's 1A there, it's 1A there. That means through that particular resistor there, the current is 1 amp here, 1 amp. Same here. So if you're doing a calculation for a resistor in a series circuit, the current is easy. It's the same everywhere. But with a parallel circuit, multiple pathways here too, it's not a current. It's not the same everywhere, is it? You'll remember when I mentioned it that we have splits and joins. For instance, here we have 4.5 amps comes to here, but at that point right there, it splits, doesn't it? 3 amps goes here, 2 amps go, probably 1.5 amps go here. So the current in these two resistors differs. Here the current is going to be 1.5 through that resistor, and here it's going to be 3. So finding the current through an individual resistor is a bit more complex and parallel, because things do differ throughout based on splits, and of course it'll join back together here, won't it, at that juncture right there. Alright, so current can be different from series to parallel, but we still are talking about current in a particular resistor. Now the best way to find voltage is to look at the tool we used in class. Let's do that. Here's the tool, and you recall it works like this. Now we got a 12 volt battery here. The symbol here for a resistor is that guy there. So note there are 3 of them. 1, 2, 3 resistors. Now recall these little circles here. This is a 12 volt battery, so voltage starts at 12. It stays at 12 until it encounters this first resistor. And then that resistor uses some of the voltage, doesn't it? The drop is 12 to 7. So we could say the voltage drop across that resistor, 12 to 7. Sometimes you'll hear voltage across. Sometimes just voltage in the resistor. In any case, it's 12 minus 7, isn't it? 5. What is it across your second one? 7 minus 3 is 4. And finally, the last drop, or last voltage, in that third one is 3 minus 0 is 3. Okay? That's how you find your voltage in a resistor. So, before I go on, please write down your code. 1 resistor. Here's a picture of that. Now let's do a calculation. Let's calculate the resistance here. Do I have voltage? I do. 12 minus 7 is 5. The series circuit, so the current is the same elsewhere. Current is 0.5. What am I looking for? Resistance 1. VIR. Find that formula, plug it in. You can solve that the resistance here is 10 ohms. And we've done a calculation just for that resistor, haven't we? Not for the whole circuit. We can do it again down here. We will get 6 down here. So to summarize here, and I'm almost out of time, we can do an Ohm's law calculation for a particular resistor. Here's a resistor, 10 to 4. His voltage is 6. We'll say his resistance is 8, and then I can do a calculation, and I can find the current here across one particular resistor. And I'm out of time. Bye.